Hello again, it's Jill Westerlund, and now we have reached the point to talk about 2C. 2C, as I told you in class, is really, in my opinion, the hub of the wheel of the Create Performance task. The Create Performance task centers around you designing a program that has 3 interrelated algorithms. And I really believe this is where you have to start planning your project. And we talked about in class types of projects that lend themselves to having 3 algorithms that work in connection with one another. And our goal is to shoot for row number 6. If you completely hit a home run on row number 6 of the rubric, rows 5 and 4 are going to take care of themselves. In fact, if you get row 5 correct, and you get points for row 5, I think you're awarded points for row 4. Something like that, I believe. So we're going to shoot for row 6 and then let rows 5 and 4 take care of themselves. Now, the instruction for this prompt is quite long and quite wordy, and it is not necessarily written in a way that most of your high school teachers give you instructions. So I'm going to try to break it down for you. I've given you some notes pages about this, and I will probably talk about it more than you want to hear, but humor me, because this is super important for this project, because this is where you really show that you understand how to be a computer programmer. So what they would like for you to do in prompts 2C is explain and show 3 algorithms that you have created. One of them must have math and or logic. My opinion is that you as a student ought to try to have all 3 of them to use math or logic. Now, some algorithms don't lend themselves to having math in them, and we understand that. So it may not be possible that every one of them have math or logic, but chances are they might. So we will try to do as much as possible to give you examples that will help you accomplish the purpose. So the instructions say, capture and paste the program code that implements an algorithm. They want it marked with an oval in your program code section. It needs to be an algorithm that is fundamental to your project. I would call this your main algorithm, your selected algorithm, or algorithm 1. So it's almost like this is your primary algorithm that other algorithms feed into. The code segment must be an algorithm you developed on your own. It should include 2 or more others. It integrates math and or logic. And you need to describe how it functions by itself independently, as well as with the other 2 to accomplish the purpose of your program. So as we brainstormed in class, a structure for this might be that you have a game and you have a way that you earn points in the game, and that's one algorithm, is earning points. You have a way that you lose points in a game. And then maybe you have a third algorithm that is your total score, and it uses the combination of the other 2. Or we talked about in class, you might have a project where you need to compute slope. Slope is the change in y over the change in x. So you may have an algorithm where you have change in y being computed, change in x being computed, and then those 2 work together to actually compute the slope. So that's how 3 algorithms might work together, and you should brainstorm more options with games or questions and answers or whatever kind of project you plan to create, chemistry apps or math apps or whatever. So now let's look at the rubric rows. Row number 4, you are going to get 1 point if you have selected code that implements an algorithm. It could be a sequencing algorithm that doesn't have any math or any logic, just a series of steps, and it accomplishes a purpose. You're going to get row 4. That is the lowest bar in your algorithm set. Then we go to row 5. For row 5, selected code, which means you have identified some code. It implements an algorithm that uses math or logic, and you have explained it, how the algorithm functions, and you've described what that algorithm does for your overall program. So the bar is higher. You've got 3 things to do to accomplish row 5. If you accomplish row 5, you will also have accomplished row 4, because by definition, you have done an algorithm and you've even gone beyond that. You have explained it. So now let's look at row 6, because this is what we really want to shoot for. Row 6 says selected code, which means your main algorithm implements an algorithm that includes 2 or more others. So that would be your total score uses points earned and points lost. Or slope uses change in y and change in x. So you have this triad of algorithms going on, and what you have to do for row 6 is you have to show each algorithm, you have to explain each algorithm, how they work and the math, and you need to tell how they function independently and in your bigger project. Now I'm going to show you the same couple of guys' work that I showed you last time. I'm going to zero in on their 2C section, just mainly so you can see how it looks. This is for a guessing game, and that doesn't necessarily lend itself perfectly to this algorithm, but it gives you the idea. So here he starts his 2C, my main first algorithm. It would be even better if it kind of had a little name like total score or something, but that's okay. He tells you, and I really want y'all to do this, this is an iteration algorithm. Iteration is actually a type of algorithm. There are 3 types of algorithms we've talked about in class. There's sequencing, there's selection, and there's iteration. I would like for you to tell what kind of algorithm it is. He explains what it does, and he explains the math that it does, and then he shows it here. This is kind of a big algorithm. It's actually multiple algorithms in one. It's probably more code than he needed to include. Then he begins to talk about his second algorithm and what it does, and then hopefully, and here he shows the second one. Then he talks about his third one and what it does and how they function. So that's one guy's idea for that. Now let's look at the other guy. Here he has his main algorithm, what kind it is and what it does. Then he talks about algorithm 2 and how it interrelates, and algorithm 3. He shows algorithm 1. He went ahead and put an oval here. You can do that. This oval has to be circled around this code in your program code document. It's not a problem if you put it here as well. Algorithm 2, what kind it is and what it does. And then algorithm 3, what kind of algorithm it is and what it does. This is calls the reset game. So if they say no, they don't want to play again. So, and obviously guessing game is a project that we do in class and a lot of people do in class, so nobody would be turning this in for their main performance task. That's why I'm showing these to you all again. So we want to shoot for row 6 and let rows 5 and 4 take care of themselves, because if you do well on row 6, you have accomplished really demonstrating that you know how to create a program with interrelated algorithms. I would tell you, you do need to read this section. An algorithm is not one line of code, so make sure that you follow that. An algorithm should not solely be a library call. You're not going to get a point for that. And if you do not identify the algorithm, in other words, you don't show it selected, meaning with an oval around it, then you're going to have a problem here getting your point. So take the time to follow the directions and demonstrate that you know what you're doing as a computer scientist. And I'm fully confident that you all can do this. Thanks.